Can you tell whether my voice is clear, audible or not? Screen is shared or not in the chat box, please. Right. So, good morning. Today we will be starting Unit 2. Right. In our last class, we have discussed the issues with decision tree learning. And as part of issues with the decision tree learning, in order to understand the issues of decision tree, in that process we have studied overfitting and underfitting. And in order to understand overfitting and underfitting, one should know what is bias and variance. So four important words, four important concepts were discussed in the last class. One is bias, variance, underfitting, overfitting, right? So four important concepts were discussed in the last class, and along with that we have seen the issues or the challenges that are there in decision tree learning, right? So friends, if you look at the syllabus, right, this is your syllabus, unit 1. So what introduction we have seen, well posed problems, then designing a learning system, means what are the design issues in a learning system or in a machine learning model, what are the design issues will be there. All there are around 8 important points under design issues which we have discussed in detail, and we have also seen a couple of case studies under these design issues. Then we have also seen what are the perspectives and issues in machine learning. Then we started concept learning and or you can say inductive learning. Under inductive learning, we have seen algorithms like finds algorithm and candidate elimination algorithm and decision tree learning. So even decision tree comes under inductive learning only, right? So after decision tree learning, we have seen what are the issues in the decision tree learning. So this is what is unit 1. Now coming to unit 2, artificial neural networks, which is very, very important. And third one is Bayesian learning. Then unit 4 is genetic algorithms, reinforcement learning. Unit 5 is analytical learning, or you can say inductive and analytical learning. So why we have these many types of learnings, what each unit actually defines, or what each unit describes, what each unit is all about. So in order to give you a broad picture of machine learning, right, I have a couple of slides wherein I can explain you what is machine learning all about, right? Then we will go to unit 2, artificial neural networks. So I hope till now whatever we have discussed in unit 1, those things are clear to everyone. So can I start unit 2? Can I start unit 2? Is unit 1 clear to everyone? Can we move on to unit 2? Please let me know in the chat box. Today we will start unit 2. So is it fine? Shall we start unit 2? Unit 1 is clear. Please let me know. We have seen finds algorithm. We have seen candidate elimination algorithm. Yeah, we have also seen decision tree, design issues, right? So unit 1. 514, you have simply typed unit 1. I did not understand. Acha, unit 1, yes sir, fine. So unit 2 we will be starting, and before we actually start unit 2, I would like to give you a broad picture of what is machine learning all about, like how many types of algorithms we have, right? And what kind of applications, or what are the types of machine learning algorithms. All those things we will try to understand now, right? So please just go through these slides. I will explain each and every slide in detail, right? Now this is an overview of ML algorithms, friends. So if you observe here, machine learning algorithms can be categorized into 3 types. Machine learning algorithms can be categorized into 3 types. I am trying to give you overview of entire subject, or overview of entire machine learning. In fact, the subject which you are studying will not cover entire machine learning concepts. But the point, even your syllabus of 5 units is incomplete. It does not cover everything from machine learning. But what is machine learning? What is there inside machine learning? Right? Overall overview of machine learning algorithms. I'm trying to explain you now. So in machine learning, there are three categories, my dear friends. One is called as supervised learning. Another one is called as unsupervised learning. Third one is reinforcement learning. Right? Supervised learning, unsupervised learning, reinforced learning. Supervised, unsupervised, and reinforcement learning. So these are three categories. Again, under supervised learning, we will get problems of classification and regression. Problems of classification and regression. Right? So before we move on, I have a question for you based on our yesterday's discussion. Can you differentiate a a discrete variable and a continuous variable? We had a discussion on this one, I think, in the last class. Discrete variable and continuous variable. What is the difference between discrete variable and continuous variable? So please let me know in the chat box. Difference between discrete variable and continuous variable. Discrete variable is categorical data. Excellent. Who is this? 508. Right? Very good. Discrete is categorical. 572 is also typing something. Only 2 students are attending or what? And continuous is numerical or real numbers. Yeah. So friends, discrete is nothing but categorical. Categorical means there are certain predefined limited number of possible values. For example, weather is there. What are the possible values for weather? Either it is cloudy, or it is raining, or it is sunny, or the weather is overcast. Like the 3 or 4 possible values I'll get. Right? Similarly, if you talk about house price, price of a house, age of a person, salary of a person, right? So for that we don't have discrete values, right? So discrete data means categorical data, and continuous variable means age, means any number. If it is a numerical data, any number is allowed, right? We don't have a predefined enumerated set of values. Like if you talk about gender, I can have only 2 or 3 values: male, female, and transgender, right? Whereas age means what? I can have any number of possible values, and it's a continuous variable. Similarly, salary, house price. What is the price of a house? Based on different parameters, the house price will vary. But can we say house price should be only these possible values? 50 lakh, 70 lakh, 80 lakh. No, it's not like that. It varies based on parameters to parameters, right? So that's the difference between a continuous variable and discrete variable. Why I asked this question is, when I come back to my slide, supervised learning, as I told you, under machine learning, we have 3 categories: supervised learning, unsupervised learning, reinforced learning. In supervised learning, there are 2 categories again: classification problems, regression problems. So friends, in classification, what is the difference between classification and regression? Means in classification problems, we will try to predict, right? We are going to predict the values which are discrete, right? Under classification, we will try to do prediction of discrete outcomes, discrete valued outcomes. For example, playing tennis example, which we have discussed in decision tree. What is the output of that playing tennis variable? Either he will play the tennis game or he will not play the tennis game, depending upon the weather conditions. So what are the possible values for playing tennis? Only two possible values, yes or no. Similarly, if you recollect our candidate elimination algorithm, in that we have seen an example where our friend will go for enjoying water sport based on some 6 parameters. So what are the possible values? Either he will go for playing water sport or he will not go for playing water sport. Like that, you have only a few set of predefined and limited number of options, discrete or categorical. For example, you take gender, male, female, transgender. Right. Suppose if you talk about performance of an employee, right? Performance of an employee. Let us say I want to give three different class labels. Performance can be good, excellent, average. So based on other parameters like number of days the employee has attended, number of what kind of jobs he has done, how successfully he has worked, how many leaves he has taken, right? What was his contribution towards company? Based on that, based on all these values, I will tell whether that employee's performance in the previous year was good, bad, or poor, or excellent. Like that, the outcome is a categorical variable. Suppose if I am talking about house price prediction, house price prediction comes under continuous variable. So friends, at the end of the course, you should be in a position to tell for a given problem what kind of algorithm will be more suitable. That much maturity you should get. Otherwise, there is no meaning in studying such a beautiful subject called as machine learning. And from my side, I'll do my level best so that you can understand each and every concept, and you can also understand the application of that concept in a real time scenario, right? So that's the reason I have not started artificial neural networks directly. I just wanted to tell you, because your unit 2 is artificial neural networks, unit 3, 4, 5 covers certain other topics. But ML is not just about these 4 or 5 concepts. ML is something beyond that. That's the reason I wanted to show you overall picture of ML, machine learning, right? So you have three categories: supervised, unsupervised, and reinforcement. So under supervised, there are two types of problems: classification problem, regression problem. Means in both cases, we do predictions only. Most of the time, we do predictions. Forecasting or prediction, both are same. Now, whenever we do prediction, if that predicting variable, if it is a discrete variable, we that problem fall under classification problem. If your outcome variable which you are trying to predict is a continuous variable, it comes under regression problem. I hope till this point it is clear. Similarly, unsupervised learning. Unsupervised learning. In unsupervised learning, there are two important problem domains again. One is called as dimensionality reduction. Another one is called as clustering. One is called as dimensionality reduction. Another one is called as clustering. So before we go for dimensionality reduction, let me explain you what is clustering, right? Whenever people define the word clustering, they try to compare it with the word classification, right? So what happened in classification problem? In play tennis, what are the possible outcomes? Yes or no? Got the point? So in classification problem, what will happen is we know what are the possible outcomes. I will give you an example, friends, to tell you what is the difference between classification and clustering. Because if you know the difference between classification and clustering, then in future you will be in a position to decide when a problem is given to you. You first of all you should know whether it comes under classification problem or clustering problem. If you can decide, if you can judge that properly, then only you can solve that problem easily. Otherwise, you will be in a wrong direction. So first of all, let us understand the meaning of clustering, right? By comparing clustering with classification. So I give you an example so that you understand the difference between classification and clustering, and in that process you understand what is clustering problem also, right? So I am going to give you an example. Listen carefully. Listen carefully. Listen carefully. Suppose I'll switch to the chat box. Yeah. So suppose friends, in this classroom, for example, there are around 100 plus students sitting here. If I ask a question, if I ask a question, how many of you are the eldest child in your family, like that? For example, if I ask a question, right, how many of you are eldest child in the family, like that? If I ask a question to all these 100 plus students who are right now in this class, right, how my output will be, what kind of output I'll get. Let us say there are around 100 students here, there are 111 students. So suppose I ask a question, how many of you are the eldest child in your family? So what kind of answer I'll get, my dear friends? What kind of answer I'll get? Yes, no, yes, no, yes, no. I am the eldest child. I am not the eldest child. Yes, no, yes, no. Boolean, right? But if you observe, in this case, in my question, I know entire 111 students will be divided into how many groups? Into how many groups? Entire 111 students are divided into how many groups? Please respond. I'm asking a question. No, the question was, how many of you are, please let me know whether you are a eldest child in your family or not. So you started typing yes, someone says no, I'm not the eldest child, yes, no, yes, no. So now at the end, all my 111 students are divided into how many groups? Two groups. Great. So I'm happy. I'm very happy that you people are responding. Thank you very much. So two groups. So what is happening in classification problem is, before the problem is solved, we know how many groups. Finally, how many groups we are going to get. So these groups are called as class labels. This is an important word. Instead of using the word group, we should say class labels. One class label is yes, another class label is no. So how many class labels I will get, I already know. So in classification problem, the number of class labels are already known. In classification problem, the number of class labels are already known, right? Why we are talking about this example is, in classification as well as clustering, finally we are going to get some groups, right? But there is a huge difference, so we are trying to understand that difference. So what happened in classification problem, I already know how many groups I will get, how many class labels are there, I already know. For example, if I ask another question, in this particular class of 111 students, how many are from what we say convener quota, how many are from management quota, and how many of you have rejoined, and how many of you are from lateral entry. So in that case, what is happening, I am dividing my 111 students into how many groups? Four groups. So if you observe again, I know that the possible groups, possible class labels are four. So one is convener quota, management quota, rejoined, and lateral entry. Like that, I am divide. I'll distribute these 111 students into four groups. So the number of class labels are already known. That is classification problem. Now coming to the word clustering, I'll give you another example so that you can understand clustering, because the sensitive part is both classification and clustering, they deal with grouping only, but there is a difference. So to understand that difference, I am giving you another example. So I hope classification is very much clear to you. Let me explain you clustering by giving another example. Right. The other example is, suppose friends, I have bought a bag of vegetables. Right. Let us say I went to a market. I bought vegetables for 1 week. Right, so I bought the vegetables in a big bag. I bought the vegetables so that I can consume them for entire 1 week. So I bought the vegetables. Now generally I do it. So generally I do it. I'll get vegetables every Sunday. I get vegetables, and what I'll do is, after getting the vegetables, I'll give that bag to my son, and I'll say, come on, separate all these things. So what my son will do, he will identify, okay, all red color items with circled shape, okay, these are tomatoes. So he will separate all tomatoes, right? He'll keep it in one place. Then peanut, some green vegetables, then potatoes. Like that, he will try to separate, and his favorite item, carrot, will be there. He will separate it. Now, this is a very common activity which I do every week. I'll bring vegetables, I'll give it to my son. But why I am sharing this example with you is, instead of my son, if the same bag was given to you, and if I ask you to separate all these vegetables, now can you tell in advance, or can I tell in advance how many groups I will get? Can anyone tell in advance how many groups I will get? Please respond. How many groups I am going to get? We cannot tell, because suppose if the bag contains all tomatoes, then only one group. Suppose if the bag contains only tomatoes and potatoes, you will get two groups. Suppose if the bag contains tomatoes, potatoes, and carrots, you get three groups, right? And if there are 7 or 8 different vegetables, you will get 7 or 8 different groups. So before solving the problem, right, do I know the class labels? Do I know the class labels? Do I know the class labels? Yeah, no, I don't know the class labels. But if you observe, ultimately in classification and clustering problem, we are trying to group the data, right? Previously in classification problem also, my 111 students were grouped into two categories, right? So whether you are from whether you are eldest child or not. So what happened? Let us say 50 students are eldest children in their family. Remaining 50 or 60 students are not eldest children in their family. So I get two groups. I am dividing my students into two groups. But the difference between classification and clustering is, in clustering we don't know the number of class labels. So we don't know class labels in advance. Once you solve the problem, after solving the problem, you will come to know how many class labels can be possible. But in classification, you already know the possible class labels. That is the difference between classification and clustering. Is it clear? Please let me know in the chat box. Did you understand the difference between classification and clustering? So in future, when you work on any machine learning project, or maybe if you get a job and if you are working on machine learning kind of applications, then nobody will tell you in your office, like a problem will be given and they will not tell you like you should use so and so technique. You are supposed to decide. Okay, meanwhile, one doubt raised by one student, 572. Yeah, but the person who buy the vegetables knows the groups, sir. Yeah, yeah, see here, fine, it's a good point. So I gave you an example only to tell you, like, the person who is solving the problem is not aware. The person who is solving the problem is not aware of class labels. He has never seen the data. So in this example, our focus should be on the data set is my vegetables bag, and the person who is solving the problem is my son. Now in this case, okay, in this vegetable example, okay, fine, I bought it, so I know it. But in real time examples, what will happen is you get data dynamically from different sources. For example, you are downloading Twitter data. Suppose you are downloading Twitter data and you wanted to study like how people are uh, reacting, responding on issues like COVID-19 vaccination. Let us say I wanted to see what is the opinion of the people on vaccination. Based on that, I would like to categorize them. Like some people say vaccination is important, it has to be done immediately. Some people say no, vaccine trials are not perfect, and even some people have already died because of taking vaccination, so vaccination is not good. Some people say I don't have any knowledge on vaccination, I am not aware of it. Some people say instead of going for vaccination, better you can improve your immunity by taking some quality food or proper food, like that. On vaccination, let us say I have downloaded 10,000 tweets. Now, from these 10,000 tweets, I am trying to group them. How many people are supporting vaccination? How many people are opposing vaccination? How many people are neutral? How many people are totally against this allopathy itself? Some people may prefer Ayurvedic medicine. Like that, if I get this kind of real time data downloaded from Twitter, I don't know, because now I am comparing this with a real time example. Now you don't find a person who has purchased the vegetables, so there is no question of the person purchasing the vegetables and he knows everything, right? So generally what happens in real time is you get the data set, right, either from your client or you will download the data set from a different source. And when you download the data set, you are totally new to data set, you don't know anything, and only after solving the problem you come to know the number of clusters in your data set. So is it clear 572? So in real time example, you will not find the person who buys the vegetables. So you will find only vegetables bag, which is the data set, and the person who solves, my son who is solving the problem, is the person who actually applies the ML algorithm. Fine. So right. So now everyone is aware of what is clustering and classification. Now we will go back to, so three categories, as I told you, machine learning can be divided into three categories: supervised, unsupervised, reinforcement. So in supervised classification and regression, what is classification, what is regression, we have seen. So they are generally used for prediction, and classification is used when you deal with discrete valued outcomes. If you are dealing with continuous variable outcome, go for regression. Now coming to unsupervised, clustering and dimensionality reduction. Clustering, what is clustering? We have seen. Now, application, see here, clustering is used in recommendation systems, targeted marketing, customer segmentation. So what do you mean by recommendation systems? Whatever offers you get in Amazon, whatever offers you get in Flipkart, same offers I don't get in Amazon, right? It is very simple. Based on my buying habits, based on the amount which I am spending, based on my type of transactions, they will decide what kind of offers should be given to me, right? Suppose even if you see in Google Pay, you get lot of rewards, right? I always get rewards on this lens card, right? I used to get regularly rewards on lens card, but what happened is I've never used it. Means those rewards are of no use. I never prefer such rewards. So over a period of time, they have changed the rewards. They have changed it to some other product. Of course, they are not giving me cash back. That's a different thing. So recommendation system means based on the behavior of the customer, based on his buying habits, based on the transactional data, we try to recommend something to the user, right? So recommendation system you see in Amazon, Flipkart, in all these e-commerce sites, even in social media applications also you will see recommendations. Facebook will suggest you it will give you some leads of friends. It will say maybe this fellow is your friend, so it will try to give you some leads based on what? Based on analysis of your previous data, right? So recommendation systems, targeted marketing, right? I keep on whatever websites I most frequently visit. Based on that, I get my digital marketing ads, right? So that is targeted marketing. So clustering can be applied on. So whatever you are seeing on black, some the text which is written in black, they are all applications of these ML techniques. So clustering can be used for recommendation systems, targeted marketing, customer segmentation, right? Like that, there are every black word is an application. Dimensionality reduction, right? So another type of problem under unsupervised learning is dimensionality reduction. It is very important, friends. Dimensionality reduction is very important. For example, I have a data set. Listen to this example carefully. I have a data set with let us say 13 parameters. I have a data set with 13 parameters, and the 14th one is the outcome variable, right? The outcome variable is, let us say, this data belongs to a telecom company data, and it is related to churn. What do you mean by churn? And any idea, sir? What is churn? CHURN. Anybody knows what is churn? It is used in telecom industry, this word. Churn means people will generally shift. No, people will move from like Airtel to Geo to Idea, then Idea to like that. We will generally change our service provider. So the rate at which people are leaving my service, that is called as churn, right? Suppose if I am Airtel, how many people are going out of Airtel to some other service, right? Every year, how many people are leaving Airtel service, how many customers are leaving Airtel? That is called as churn rate. Suppose if I want to study, why I want to understand what is the main reason why people are leaving Airtel. Yeah, churn means move out. It's like move, or you can say move away. So let us assume I am dealing with the problem of churn analysis. Now what I'll do, I'll have a data set with 13 parameters. So parameter one is what type of connection it is, whether it is prepaid or postpaid, and he was in which scheme, right? And how frequently he was making STD calls, ISD calls, what was his mobile data pack, and how much mobile data he was consuming, how much mobile data was getting wasted, or if the mobile data exceeds the limit, how much extra amount this fellow was paying to us, right? And how frequently he will make calls in the night time, how much data is being consumed during night, how much data is consumed during daytime. Like that, let us say there are 13 parameters, and the 14th parameter is the churn value, which says whether this fellow has left Airtel or not, right? So 14th parameter is outcome, yes or no. Yes means he has left Airtel and he went to some other service. Now tell me, really all these 13 parameters will play an important role in deciding the churn value? Do you think all 13 parameters are really important in deciding the churn value? Please respond. Do you think all 13 parameters are really important in deciding the churn rate? All 14, all 13 parameters are important. Okay, if you think all 13 parameters are important, then comes the question, all 13 parameters are equally important? All 13 parameters are equally important. So M naught says no, sir. 514 says yes, sir. So the point here is, my dear friends, it all depends on a data set, and it is not no every time, it is not yes every time, right? It is not yes every time, it is not no every time. But that's the reason what we do is we will go for dimensionality reduction. So what we will do under dimensionality reduction is, the name itself says dimensionality reduction. What we will do is we will try to identify if my outcome variable is dependent on, let us say, 13 parameters. I need to identify, are all 13 parameters are really important? Are they really having the influence on the outcome? If so, then what is the priority of every parameter? Why we are talking about dimensionality reduction is, the reason for talking about dimensionality reduction is we will be dealing with, generally we will deal with huge amount of data, right? So my data itself will be, the number of records will be in lakhs, 5 lakhs, 10 lakhs, 20 lakhs, like that. And if the number of parameters are 13 parameters, and if I start analyzing them, it will become very, very costly for me. And one more thing, that if all 13 parameters are not equally important, then the parameters which have less influence or less importance, they may affect my final machine learning model also. So what we do in dimensionality reduction is, we will first of all try to identify the importance or influence of all parameters. If I have 13 parameters which will decide or which will affect the churn, in that I will try to identify what are the strongly influencing parameters. What are the strongly influencing parameters, and what are the parameters which are not influencing strongly on the result? So out of 13, let us say if there are 5 parameters which are strongly influencing, then I will try to improvise on only those 5 parameters, because our objective is not only to analyze the churn, we want to improve also. I want to improve. Suppose this year, if 10,000 people have left Airtel and switch it to some other network, next year I don't want it to be 10,000. I want it to be less than 10,000, 5,000, 4,000, like that. So how do I reduce this? I should know what are the most strongly influencing parameters, what are the most influencing reasons for people to leave my Airtel. I need to understand. Then in those few strongly influencing parameters, I will make some changes. I will come up with some new offers so that people will not move away from Airtel. The rate of churn can be reduced. So suppose if you think all 13 parameters are equally important, I can't make changes in all 13 parameters, right? So I need to decrease the churn rate. At the same time, I need to run my business also. So out of 13 parameters, what are the most strongly influencing parameters? Let us say once the mobile data pack is completed, after that whatever extra mobile data is using, for that I am charging some what we say, some good amount of charge is imposed on the customer after mobile pack is completed, mobile data pack is completed. So I came to know that that is the most strongly influencing parameter. So what I will do, I will immediately announce that, okay, once your mobile data is completed, for extra data whatever you are using, for that whatever rate is there today, that is reduced by 50%. Then my customers are happy, right? So like that, out of 13 parameters or out of all parameters, we need to identify what are the strongly influencing parameters. And once they are identified, we can make some corrective decisions, or we can make some decisions such that the churn rate can be reduced. So dimensionality reduction is very, very important point. And even the problem space becomes very, very complex. So that's the reason I don't even want to deal with unnecessary parameters. What are the most important parameters? Only those parameters I'll take into account. So I hope dimensionality reduction, the word is clear. Next, reinforcement learning is another category, right, or another type of ML algorithms. So reinforcement learning means you learn by real-time application. Means, for example, if you take this, what we say, robot navigation. See, the example is already there. You can think of driverless cars. So what these applications do is we deploy them, we really deploy them, and we start using them. And when they start working, they learn from their mistakes. Robot navigation, driverless car, real-time decisions, game AI, our checkers game, chess game, right? All these things, they come under the category of reinforcement learning. So just imagine I created a machine learning model to play the chess game, and I gave training examples of only Vishwanathan Anand. So my chess game machine learning model knows the strategies of Vishwanathan Anand, right? And maybe there are so many other players in the chess field or in the chess game who are totally different from Vishwanathan Anand, right? And suppose if my machine learning model is playing the chess game with Kasparov, who is also a world champion. Now, if what happens is, let us say my machine learning model has lost the game. It means even though I trained it with the examples of Vishwanathan Anand, my model failed. It lost to Kasparov. It means that I can't teach everything to my model in the very beginning. Sometimes it should learn by mistakes. So you learn by experience, you learn by mistakes, and all such cases, they come under the concept of reinforcement learning. So friends, see here, machine learning, unsupervised, supervised, and reinforcement. So under supervised, again, we have classification, regression. Again, in regression, these are all five different algorithms or five different techniques that can be applied. In classification, these many techniques are there. In reinforcement, these many techniques are there. In clustering, these many techniques are there. But if you carefully observe this slide, oh my God. So if you observe this, in the unsupervised learning, the first one, if you see the bottommost box, what we are using is deep learning and neural networks. So neural networks is useful in unsupervised learning. Similarly, in supervised learning also, you see under regression, neural networks is a word which you can see again. Now coming to classification, right? In classification problems also you can apply neural networks, but it is not mentioned, but still you can apply neural networks here also. And see here, in reinforcement learning, you find artificial neural networks. So neural networks are artificial neural network, both are same, sir. So if you observe in all three categories, unsupervised, supervised, and reinforcement learning, in all these three, neural networks can be applied. So neural networks, nothing but artificial neural networks, can be applied in all three categories of ML algorithms. So artificial neural networks is very, very, very important. Will you accept this point? Artificial neural networks can be applied in all three types of problems, and hence it is very, very important. Is it not? Right. So in order to understand artificial neural networks, so friends, why this much discussion was done, why I have spent entire one class on introduction part is so that you should understand importance of neural networks, right? So our second unit is artificial neural networks, right? So before getting into artificial neural networks, I just wanted to uh, bring in some awareness so that you know what are the varieties of problems that can be solved with machine learning. And in every category of problems like supervised, unsupervised, reinforcement learning, whatever may be the type of machine learning technique you apply or algorithms you apply in all three categories of ML problems, neural networks can be applied. That's the reason neural networks is very, very important. So friends, before we go to artificial neural networks, ANN, I am writing short form of artificial neural network as ANN. So before we begin ANN, one should know the following fundamental concepts of linear algebra. One is called as a scalar, vector, matrix, tensor. Right? If you might have heard about a software called as Tensorflow. Tensorflow, right? So scalar, vector, matrix, tensor. What is a scalar? Scalar is just a single number represented using lowercase italic font. So here, this let n belongs to n, small n is the scalar, but it should be italic. I have not used italic font, right? Vector is an array of numbers, right? An array of numbers is called as vector. A single number or a single value is called as a scalar, because we are going to use all these things in our neural networks, my dear friends. Matrix, it's a two-dimensional array which is represented like this. A is a real valued matrix with m rows and n columns. Tensors are nothing but arrays with more than two dimensions. Array with more than two dimension is called as tensor, right? So Tensorflow is a software you might have heard. So it's a package, right, which is used in Python, especially to implement neural network algorithms. We use Tensorflow, right? So name itself says Tensorflow, means it deals everything with the form of tensor. So what is a tensor? It's a multi-dimensional array. It's an array with more than two dimensions is called as tensors. So these are four definitions which we have seen, but beyond that, some other concepts of linear algebra are also important so that you can understand artificial neural networks. So before we move on to artificial neural networks, we will be discussing some more fundamentals of linear algebra. Then we will go for artificial neural networks, right? So that's all from my side. Please let me know whether you have understood today's class or not, everything is clear or not. Please let me know in the chat box. Please respond. Everyone should respond, please. Another important point is, friends, we have a lab for this subject, and the lab has to be implemented in Python. So what I do is I will share some material, learning material on Python, right? So that you can learn Python. And after first mid exams, after first mid, what we will do is we will also start implementing our laboratory courses. Labs will also be conducted. It will not be like last semester where you have simply attempted exam on a paper and that happened, right? So we will be doing labs also. So morning session it will be theory, and afternoon session it will be lab. So labs will be conducted. It is compulsory. Without practical knowledge, it will be very difficult. You cannot understand any subject. So lab is implemented in Python, so you should know Python, and I can't teach you Python simultaneously or separately. So what I'll do is I'll share some material from where you can learn Python basics, and while doing lab problem, whatever advanced concepts of Python are used in that lab, I will explain them, so that will not be a problem. So meanwhile, I have shared in before starting this class, I have shared you the textbook of Tom Mitchell, machine learning textbook, and I have shared you the link from where you can get the slides of Tom Mitchell, right? And apart from Tom Mitchell, I am referring another book which is called as Deep Learning book by Ian Goodfellow, right? Even that book, if you want, I can share it. So meanwhile, please let me know. Yes, understood, clear, sir, fine. So, and for your mid exam, whatever we have discussed in unit 1, means only unit 1 concepts will be considered for mid 1, right? And in 1 or 2 days I'll give you the material. I am trying to spend some time on it because of my what we say, because of my very tight schedule, right, I am unable to prepare the notes.